Hey kiddos, today we are going to be learning lesson 2, which is called Finding and Comparing Unit Rates. In this lesson, we are going to continue to learn how to use fractions, decimals, and percents to create ratios and rates and to compare those ratios and rates with each other. We have the same vocabulary words as we did in lesson 1. And your resources are as follows. We will talk about these again at the end of this video. I suggest right now you click on the Desmos Scientific Calculator so that you can use that as you work. So just to review, a unit rate is a ratio that compares two measurements. And one of those measurements has to be the number 1. So if you look at the illustration, you can see that a rate might be something like 60 miles in 3 hours. That's comparing miles to hours. And a unit rate would be simplifying that 60 miles in 3 hours to 20 miles in 1 hour. And we would say that as 20 miles per hour. All right, and the way that they simplified that was they divided both the numerator and the denominator by 3 so that the denominator became the number 1. That's what makes it a unit rate, is when your denominator is 1. We could also take something like 40 words in 2 minutes, which is a rate, and simplify it by dividing each of these by 2. And that would give us our unit rate, which is 20 words in 1 minute, or we could say 20 words per minute, right? It's always easiest to compare rates when they are written as unit rates, and that's what we're going to be looking at today. All right, so this is an example of a problem that would ask you to compare unit rates. And basically, one of the biggest hints I can give you is that when you want to compare unit rates, you're going to divide each rate to find the unit rate. We're using division. So here's a problem where I'm trying to figure out which one's the better buy. I have 2 different bakeries that I'm looking at. Ava's Bakery sells 12 cupcakes for $10, and the Publix grocery store sells 10 cupcakes for $7. I want to know which one is the better buy. So what I'm really trying to figure out is, how much am I paying per cupcake? And in order to figure that out, this is what I would do. I would first start out by trying to figure out how much money I'm going to pay per, that division bar means to divide, per cupcake. And just like yesterday, this is the most important part, is getting what I call the setup done correctly so that you know which number is going to go in the numerator and which number is going to go in the denominator. All right, so if we're looking at Ava's Bakery, we're looking at this information right here. 12 cupcakes for $10. And so if we follow the setup that I've written over here, I'm going to put the money on top. So my 10 goes on top because it's $10. And the number of cupcakes goes on the bottom, which is 12. Now, guys, remember that I put cupcakes on the bottom because I want to know how much it is per cupcake. So I want to get my denominator to be 1. I want to know how much I'm paying for 1 cupcake. That's why cupcakes went in the denominator. All right, so I know that it's $10 for 12 cupcakes. What I can do with that now is I can set up that proportion that we were talking about yesterday, where I'm going to keep my money in the numerator and my cupcakes in the denominator. And so I know that I've got $10 for 12 cupcakes. I'm going to set up a new fraction that tells me I don't know how much I'm going to pay, but I want to know how much 1 cupcake is. All right, so this second step is called setting up the proportion. And now that I've got that proportion set up, I can use cross products, right? So I can multiply 12 times x and get 12x. And then I can multiply 1 times 10 and I get 10. And I'm going to set these equal to each other. And now I need to solve this equation. Remember, I'm trying to get the x by itself. So I'm trying to get rid of the 12. So I'm going to divide both sides by 12. And I'm going to get some funky answer. So I'm going to get x equals 0.85 3 repeating. And now it's time for me to interpret that information, right? So what that means is I need to think about, well, what did I just figure out? Well, I figured out what X is, and X is on the top, so it represents money. And so what that tells me is that my numerator here for X is 0.83, and I'm rounding now, right? So the next digit after this repeating 3 would be another 3, and this 3 doesn't round up. So therefore, this is going to be about 83 cents, because it's money, for 1 cupcake. Okay, so now we are going to repeat that process. We're going to go ahead and do that whole entire thing all over again for Publix to figure out how much we're paying per cupcake. Okay, so again, I'm going to go back to that setup. I'm still going to be using the amount of money it costs per cupcake. All right, and in Publix case, it costs $7 for 10 cupcakes. All right, so I'm going to go ahead and input that information. I'm going to put the 7 on top, $7 for 10 cupcakes. And I'm going to go ahead now and set up my proportion. I don't want to know how much 10 cupcakes cost. I want to know how much 1 cupcake costs. So I am going to do 7/10 equals, I don't know how much money it's going to cost me for 1 cupcake. Okay, and now I'm going to go ahead and do those cross products again. So I'm going to multiply 10 times X, which gives me 10X. And I'm going to multiply 1 times 7, and that gives me 7. To solve, I'm going to divide both sides by 10. And I would use the Desmos calculator at this point, and I would put in 7 divided by 10. And I'd end up with X equals 0.7. And so again, I need to kind of figure out what that really means, interpret my answer. And so what that means is that I would be paying about 70 cents, not 7 cents. The 0 is invisible after the 7, so we stick it in after the 7. So that's about 70 cents for 1 cupcake. So all things considered, it looks like Publix is the cheaper value. I can get the cupcake for 70 cents each, where at Ava's Bakery, I get the cupcake for 83 cents. This is an example of comparing unit rates. There is another strategy that you could use, and some kids might say, well, Miss Scanlon, this seems a little bit more complicated than is necessary. And I'd say, you know what, you're probably right. You could do this in an easier way. So for those of you who understand it by just looking at it, you look at 10/12, and you say, you know, you want your denominator to be 1. Well, you could just divide the denominator by 12, because 12 divided by 12 is going to give you this 1. And whatever you do to the bottom, you do to the top. So you could certainly just divide 10 by 12 to get your answer. Right? That's another strategy if you're not wanting to set up that entire proportion. Some kids really like the proportions, they're good at them, and so it just makes more sense to them. All right, you're going to get the same answer either way. You get 0.83 repeating if you divided 10 by 12. All right, so whichever method you prefer, you are welcome to use. We're going to go ahead and look at another example. So now this one would be an example of scaling, trying to figure out how many lemons you would need with a given number of cups. And in your homework that you guys are going to see, these graphs are going to be interactive. You will be allowed to literally grab onto this graph and drag it where you want it to scale the number of cups, and it will scale the number of lemons at the same time. So it's a pretty cool tool to give you a visual representation of what's happening, but I'm going to show you the math process on how to do this. Let's read the problem. The problem says, for Jason's lemonade recipe, 5 lemons are required to make 15 cups of lemonade. At what rate are lemons being used in lemons per cup of lemonade? And they give you the setup right here in this last sentence, right? So they are telling you that they want you to do lemons per, remember that's division, cup of lemonade. So lemons go on top and cups go on the bottom. And when they're asking you for at what rate, this question is really asking you for the unit rate. That's what it's saying. At what rate, meaning what's the unit rate? So what I'm going to do is I'm going to take the information that I'm given over here on the left-hand side where I've got 5 lemons and 15 cups. And I'm going to go ahead and write that in this same setup where lemons are on top and cups are on the bottom. So I have 5 lemons and I have 15 cups. And I want to know how many lemons I need per cup. All right, so that means I want my denominator to be 1. I want to know how many lemons I need for 1 cup. So that is my unknown up here. I don't know how many lemons that is. So again, I have a proportion right here that I can either use cross products to solve and do 15 times x, and then do 1 times 5. And then to solve that equation, I would divide both sides by 15. And I would end up with 5/15. In this case, I'm choosing to leave it as a fraction. If I wanted to write it as a decimal, that would be fine too. I can simplify this fraction by dividing both the numerator and the denominator by 5, and that would give me 1/3. And maybe this makes sense why I left it as a fraction, because what this is telling me is that I would need 1/3 of a lemon if I had 1 cup of lemonade. All right, so for me, when I'm in the kitchen, I understand what 1/3 of a lemon is. I could take a lemon and I could cut it into 3 equal pieces. However, if you wanted to actually do the math and do 5 divided by 15, you'd end up with 0.3 repeating. And again, you could be using Desmos to get this answer. And 0.3 repeating is the same thing as 1/3. But the reason that I don't use 0.3 repeating is because it doesn't make as much sense to me when I'm in the kitchen. I'm not really sure what 0.3 repeating is of a lemon, so I prefer to leave it as a fraction. However, both of those answers are identical, therefore either answer is acceptable. Okay, guys, remember that you do not have to do the cross products. There is another strategy, right? Instead, you could just say, well, how do I get from 15 to 1? And you could say, oh, well, I divide it by 15. And to get from 5 to x, I'm going to do the same thing as I did on the bottom. So I divide 5 by 15. And I get the same answer. I'd either get 1/3 or I get 0.3 repeating. All right, we're going to do one more example. So this last one is an example of comparing different scenarios when we have to do some conversions. So let's read the problem first and try to figure out what we're dealing with. The question says, given the speeds of each runner below, determine who runs the fastest. And then it gives us 4 different runners. The first runner, Noah, runs 10 feet per second. Liz runs 113 feet in 9 seconds. Debbie runs 1 mile in 441 seconds. And Will runs 843 feet in 1 minute. And we're trying to figure out which one of those runners runs the fastest. So to determine who runs the fastest, we're going to find the unit rate. All right, we're going to convert each one of these into unit rates, and we're going to make sure that we're using common units of time and also common units of length. So what does that mean? Well, that means that 3 of these people are given in terms of feet, and 1 of the runners is given in terms of miles. So we've got to make sure that we choose the same unit of measure. And so I'm going to choose to use feet. Right? It's almost always easier to convert things to the smallest unit of measure when more than 1 unit of measure is provided. So feet is going to be what I choose to convert the distance to. And then if we look at the times, we've got the same kind of scenario going there. We've got 3 of them that are in terms of seconds, and we have 1 of them that's in terms of minutes. So again, because it's easiest usually to convert to the smallest unit of measure, I am going to go ahead and use seconds. So this is going to be my setup. Now, if you happen to do miles per minute, you could still convert all 4 of these people into miles per minute, and you could compare them, but it's a lot more work because there's only one person who's got miles and there's only one person who's got minutes. So it seems like a lot more work to do those conversions instead. All right, so what I'm going to do now that I've kind of figured out what I want to create my fractions to look like, is I'm going to start going from the top and looking at what each of the runners' unit rates would be. So we're going to start with Noah. All right, and so Noah's setup would be feet over seconds, and he runs 10 feet in 1 second. That's what per second means. I'm going to use the abbreviation of SEC for seconds. So Noah's was already done for us. We didn't have to do a single thing to Noah. All right, so I'm just going to rewrite it over here. He is going 10 feet. And I'm going to use a backslash, and then I'm going to use SEC. What that stands for is 10 feet per second. That's how fast he's running. All right, now we're going to go on to Liz, and we're going to calculate Liz. Okay, so Liz goes, again, we want feet on top and seconds on the bottom. She goes 113 feet, and FT is the abbreviation for feet, in 9 seconds. All right, now in order for me to compare that to Noah, I have to create a unit rate. I have to get this denominator to be 1 second. So again, I can either do the proportion and use cross products, or I could say, how do I get from 9 to 1? And that's by dividing by 9. And then how do I get from 113 to my answer? Well, whatever I did at the bottom, I'm going to do to the top. So I'm going to take 113 and I'm going to divide it by 9. Okay, and if I brought that over to Desmos, my answer would be 12.5 repeating. Okay, so what does that mean? Well, that means that Liz runs about 12.5 repeating feet per second. So already I can tell that Noah is running faster. I have to repeat this process for Debbie and for Will. I'm going to actually clear out Noah and Liz down here so I have a little bit more room. Hopefully, if you're following along at home, you're just keeping it all written down on one piece of paper. All right, so now here's something that you may not know. You need to know how many feet are in a mile. I'm going to give that to you. It's 5,280. There are 5,280 feet in 1 mile. Okay. Hopefully, if you're ever given a question like this, they will provide you those conversions. All right, so instead of using 1 mile, I'm going to actually use that 5,280 feet when I calculate Liz. All right, so we're going to do Liz next, or sorry, Debbie. We're going to do Debbie next. All right, and Debbie's number of feet, I just told you, instead of it being 1 mile, I'm going to call that 5,280 feet. And it takes her 441 seconds to run that distance. So again, what I'm going to do is I'm going to create that proportion where I want to know how far she can go in 1 second. Okay, and again, I have 2 choices. I could do cross products, or I could simply divide. So to get from 441 to 1, I'm going to divide that by 441. And whatever I do to the bottom, I'm going to do to the top. And this would take us a long time to do long division for, so instead, I'm just going to use Desmos calculator, and I'm going to take 5,280 and divide it by 441. And I get some crazy answer. I get 11.9727891, and then my calculator cuts it off. So because all I need to do is to compare this to Noah, Liz, and Will's feet per second, I could probably round this. So I'm going to just choose to round to about the hundredths place. Right, I might need to go farther into that decimal depending on what the other numbers are, but I think that this will give me more than enough information. So I'm going to use this 2 to round. 2 does not round up. So I'm going to say that Debbie runs 11.97 feet per second. And then we've got one more to go. So finally, we have to figure out how many feet Will can run in 1 second. And so I'm going to look at his problem, and I'm going to notice that we are dealing with a minute. So hopefully that's a conversion that you already know. Hopefully you know that there are 60 seconds in 1 minute. So instead of using this 1 minute in my fraction, I'm going to use the number 60 for the number of seconds. Okay, so Will runs 843 feet, and it takes him 60 seconds. Right, and again, like I have before, I'm going to set up that proportion. I want to know how far he can run in 1 second. So I could either do cross products, or I could, again, like I've been doing in this problem, say to get from 60 to 1, I'm going to divide it by 60. Whenever I do to the bottom, I do to the top. All right, so I'm going to take 843 and I'm going to divide it by 60. And that's going to give me 14.05. All right, so at the end, I know that Will can go 14.05 feet per second. Right? So what we did was we converted everything into like units of measure. And now we're able to figure out who can run the fastest by just comparing those numbers. So I can see that Noah runs 10 feet per second, and 10 is the smallest number of feet. 12.5 is larger than that, 11.9 is larger than that, and 14.05 is larger than that. So this means that he's the slowest. He's only running 10 feet. So if you think about a race, this is the starting line. Geez, I'm really bad at drawing people. All right, but here's my runner. He's starting. When the gun shoots off, he goes 10 feet. And that took him a whole second to get there, right? So the person who has the greatest number of feet is the fastest, right? So because Will can get 14 feet in 1 second, he is the fastest. Okay, so I would write an answer that would say something like, Will is the fastest because he runs 14.05 feet per second. Okay, so going back to your resources pile, what you will notice is that there are 2 different support videos that are provided for you as you start working on your work in Delta Math. If you are confused, you can look at this top video if you want to work on practicing computing and comparing rates. Or you could use this bottom video if you're struggling with just finding unit rates. Okay, so there are 2 support videos for you if you need them. What you are going to do right now is you are going to jump onto Delta Math. You are going to look for the assignment that says comparing and finding unit rates, and you are going to complete that assignment. As always, message me with any questions and let me know how I can help.